Hello all. Today I'll be talking about LLM agent versus tool augmented LLM. So basically, I'm trying to propose here that you don't need an agent for all your tasks. Like if you have a single function objective, you don't need to call. You need not create an agent, or you need not call an agentic system. You can just call directly the tool of the function, and then you can summarize the result in the and then you can summarize the result to LLM, and then get the result, the final result. So why do we need this? So let's go to some of the basics. So an LLM agent. So an LLM agent is nothing but an agent is nothing but an LLM plus tools. As we all know, LLM can only predict the next token. It cannot call a function, it cannot do a REST API, it's a stateless machine. So we have an AI app or an orchestrator, or we also call it as an harness code, which calls the LLM, and then based on the results, it can call the tools. So in the context memory for the LLM, you list all the functions and like the tools with a summary. And when you ask a question, when a user asks a question, the LLM is gonna say that, okay, now I need this tool. And then in your code, you're gonna call the tool. It might be a REST API, it can be a simple function, and then you give back the result to the LLM along with all the history. If you don't give the history, it's as I told, it's a stateless machine, right? It doesn't know why this response is being given. So you need to say, this is the user query, this is the response from you to call a tool, I called a tool, this is the result. Then again, the LLM can ask for more tool invocation, or it can finalize the answer, and it can give back the result to the user. So that's what is explained in this figure. Yeah, so here we have the LLM agent. The user sends a query, passed to the LLM. LLM might request for a tool access, and then there is an observation, in the sense it's routed back to the LLM. LLM decides again what to do. So this loop is the LLM loop. This is offline, we can say. It's offline to LLM, in the sense the AI app generator or the AI app code has to call the tool, get the answer, and then finally LLM might say, I don't need the tool now, I can finally deliver the answer, and the final answer is delivered. So this is like a multi-step. It consumes a lot of token here. And let's go to the tool augmented LLM. So here we note the specific goal for our workflow. Like in my example, I'm going to use the Confluence, look up some user query in the Confluence documents and summarize the result, or the Atlassian Jira, like look up some issues and then summarize. So these are the two tasks I have. These are like well-defined tasks. So I'm not expecting anything else. Like this, it's not a generic chat where you say hi, hello, how are you, what's the weather, what's the FIFA World Cup score, right? We are not gonna do that. If you do, it's gonna fail. So we are very strict in that. So for example, if you have the Confluence tool, augmented LLM, so the user is ask a question, we're gonna directly call the tool, that is a Confluence tool, get the output of the tool. These are all offline work, I would say. Then we call the LLM with this context, and then we get an answer. Or it can be, for the Jira example, the user inputs a Jira ID. We are going to directly call the Jira REST API, get the answer, then we are going to send it to LLM, get the final answer. So it's a single step. The tool is called externally LLM, mainly summarizes. So you can see the differences here. The autonomy wise, the tool thing is like there's not much atomic here, autonomous here, like we just call the tool and the LLM. But in the LLM agent, the agentic workflow, there can be like, it's autonomous here in the sense it can have, you can say like maximum 5 observation loop you can do. So it can ask multiple tools to get the perfect answer here. It's a single step. The tool augmented LLM is like multi-step. Tool uses the complexity is lower. That's one of my main argument here. If you use the tool augmented LLM, the complexity is much lower, and if you're using agent, it's higher. Token usage is lower, higher. Yeah, this is the main point. The token usage is the main point. So when you call an LLM agent, you need to set the context memory, right? So you're gonna say, you will have what the agent does, what is your, like first you have a system prompt, then you have what does the agent do, what is your profile, then you might have skills.md, like it's a generic system prompt. I've been talking, like you can ignore the skills and all for this discussion, but still you need to pass the tool summary. So you need to tell the LLM that if you want to call the Jira database, I have a MCP tool. If you want to call the Confluence, I have a MCP tool. Maybe if you need a calculator, I have a calculator function. So you need to write down all the tools in the context memory, right? And then you have the conversation history. You also have the tools output, like as I told, it's a stateless machine. The second time when you call the LLM, if you don't have the tools input and output, it will not know like what's happening, and it will hallucinate and provide some vague answer. So your context increases, you're burning the token, right? But in the tool augmented LLM, we are not burning the token, in the sense we just send the relevant data. So this is actually kind of a RAG here, retrieval augmented generator. So it's kind of RAG here. It's a plain RAG. So let's go to the code. Yeah, first let's talk about the tools augmented LLM.py. So this is a simple code. I don't want to go much into the code, only the basic stuff which is helpful in understanding the concept of tools augmented LLM. So this Python script is for Confluence page. So the user is going to ask, like you can have a Confluence, mainly this is a Confluence MCP server hosted in your corporate environment, where there are a lot of Confluence pages, documents and all, and the user is gonna input a question, like it can be what is LLM, right? Or get me the like some feature in your company. Once the question is asked, let's go to the ask question. It's gonna search the Confluence. Before that, okay, sorry, I need to start from here. So main is Confluence. So first we need to initialize the MCP. So for this Confluence example, I'm gonna use the MCP server, and for the Jira example, I'm gonna use the direct REST API call. So what I'm proving here is that you don't need an agentic workflow to make an MCP call. You can directly call MCP server directly you can directly call from your code itself, right? Not through the LLM driven events. So first we need to initialize the MCP. We send the initialize payload. Yeah, so we have the initialize payload. You need the MCP URL. So I don't want to go like deeper into these setups. So this is probably provided by your corporate Confluent URL. So the main concept here is that how we are calling the tools without the agentic workflow, right? So here you call the MCP, you set the initialize flow, and then you come back here, you get the response, go back to the code. So first we initialize it, everything is success, then the user inputs the question, then we are gonna go to last question. So when the user asks a question, we are gonna extract the keyword. So okay, I don't want to again go deep here, like we're just filtering out all. If you're asking what is LLM, right? We don't want to send what is LLM to the Confluence query. We just want to send LLM, right? So we're just filtering out few words. This is not gonna work if you are sending WHT instead of what. So please, this is not a course for. So if you want that approach, you can directly call the LLM, right? So that's a agentic workflow. You can say what is LLM. You can say WT. You can do a mistake. Still, it's gonna work. But here in our flow, we don't want to call LLM for everything, right? So just have some native filtering here so that the question is extracted. So the question is LLM for here. So we get that keyword, then we call the tool, which is again the tools call. Like earlier we had called initialize, now we are calling tool call with our question. So once that's done, we get the answer back. Let's go back to the, yeah, we call the tool, we get the extract, we get the answer back, we format the answer. Then okay, this is a step where we call the LLM. So here we are saying this is our system prompt. You can say you're a helpful assistant, and we are providing the data for you, Confluent data. So for the question, cite the page titles. So it's like the Confluent MCP server is gonna return, that call is gonna return you maybe like 4 to 5 pages with all the data in that, and then you're gonna send like that formatted is our MCP server tool result, and this is a question. So now the LLM is gonna reply back with the summary of the LLM, what is LLM question, right? So that we are gonna return back to the user. So this is not a React, right? This is only a single step. So though we have a while loop, this is only for asking the next question, right? We are not adding the history or anything here. It's, as you see, it's like a plain, we are not doing question plus plus or anything like that. So this is the first example where we're directly calling the MCP server instead of LLM calling the tools, right? So the next one is the Jira Augmented LLM. So here, similarly to the Confluence Augmented LLM, here this is the Jira Augmented LLM. Here we are not even having any MCP server, we are directly calling the Confluent. We are directly calling the Jira URL. So before starting, you need to set up your corporate, or if you have your own Jira, I'm not sure if people have their own Jira database. Yeah, so get the API token from Atlassian, get the Jira. I feel this Atlassian API might be, it's like a, I've taken the common code, I'm not sure, but yeah. So just have all the API key for your corporate Jira or your local Jira instance. Then okay, here it's much more simpler. We don't have any filter or anything, right? We expect the user to issue, like enter a Jira issue number, right? Like a 1234, like 2048. We don't expect anything else. You're not explaining anything here. If you're not asking questions like what is the Jira status. If you do, it's gonna fail, right? We are very clear on our objective, right? Just give the number, right? The Jira number, or you can type my or mine. Basically, it's gonna give your entire Jira numbers, which Jiras are assigned to you, right? So if you're lucky, you might have many Jiras under your name, so it's gonna give that list. Or if you have done all your task, it will be empty. So here you can see, input the Jira number. If it is my or mine, it is gonna list all the issues under your name. So these are all REST API call. We are directly, there's no LLM involved. We're just calling, making a REST API with your. That's the reason you have your Atlassian or your Jira ID and all the, sorry, your user ID and your Atlassian API token. So it's gonna query and give your Jira list. That will be list of number. And once you get the list of number, you can the next input is pick an issue. So enter the number, enter the Jira number, right? So either you can enter directly the Jira number here, or you come through the my list and then pick up a Jira number that is assigned to you. And then in both the cases, we are gonna call the show issue. So here again, it's a REST API call. We are gonna fetch the issue. So this is gonna give the data and the comments, the description of the Jira and the comments. And once you get that, that's the show issue. Fetch the issue, right? And then summarize the issue. This is what is very important for us. So here we are gonna call the LLM, generate the summary. So I've just created a caching mechanism here. So I don't want to call the LLM if there is no Jira data change. So for the first time when you call a Jira number, maybe 1234, and it's gonna, since there is, the cache is empty, it's gonna hit the like we have already got the Jira description alert. So that's a REST, that is a REST API. We have got all the data, whether to call the LLM or not. That is what the caching does. So if you have already called once, in our case it's the first time we are calling, so it is not called. So this code is gonna hit the else condition, send the data and the comments for that Jira number, get the summary, right? So and then you're gonna save it in the cache. So the next time you call, there is no changes in the Jira for that particular Jira. It's not gonna call the LLM. So you're again saving token here. You don't want to call LLM again and again with the same. If nothing has changed in the Jira, why do you want to summarize the data? You can just send back the old summary. That's the reason I have this caching mechanism. It is like little bit of sidetrack, but yeah, my main focus on this entire talk is how we can save the tokens. We did not call LLM every time. So we can go back to the figure again. So this is our regular LLM agent workflow where we don't have any control. Like you do have control, but we don't want to be fully in control of this loop. That's why it can do multiple calls. So tools are nothing but the Confluent MCP server which we talked, or the Jira REST API call, right? But in our tools augmented LLM design, we directly call the tool, which is hard coded. Then we call the LLM to summarize the result and send back the answer. So with this, we use less token, but it's also less autonomous. It's not an agentic workflow. It's like a simple rack system, but at the end of the day, it saves token. That what matters. Also, I wanted to prove that agent is nothing but, like, it's not all those are fancy words. Like there's a lot of engineering, but still LLM is a prediction machine, right? It doesn't do anything else. It cannot call the tool. We are the, as a developer of the AI app, they have to call the tool and get back the result, right? So I wanted to prove that point. Yep. Hope you liked the video.